So Larry, we've had some questions from the Geek Force on the DAC PCB and why you anticipate it's going to sound amazing. Can you show us a little bit about what you're doing?
Okay, let me brief the background a little bit. Circuitry-wise, schematic-wise, DAC is very similar to the Geek Pulse X, FI actually. So these two schematic-wise shares a lot of things, and almost 98% the same. But I want to give you guys some differences between the Vi board and Geek Pulse board. This is the thing I will tell. The other important stuff is Vi is really a little bit, not a little bit, actually it's about 30% bigger than Geek Pulse and LPS altogether, right? The chassis is much bigger. So it gives me one thing I love the most, space. The more space I have, I can work on it. I can make the components and every layout in groups. It will make it easy to see an even cleaner layout. I got a lot of good feedback from the Geek Force that, okay, I love the layout for the Geek Pulse. I really love it. It looks neat and consistent. I really appreciate that. But you will see that DAC, we make it even better. We never stop, no compromise. So let me show you the same thing I did for Geek Pulse. I'll do it for DAC once more. So you will see different connectors. Cheese it, good. So different connectors. This is the Toslink, and next one is the RCA. No, sorry, SPDIF input 1, input 2, and AES input. And this is the USB. And after that, every digital input on the right, we see every analog output on the left. They are pair of XLR and pair of RCA. So basically, the layout here is exactly the same like Geek Pulse. No problem, right? But here's the differences. That's the overall layout. You will start seeing some blanks like here, 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 here. Why? Because now first of all, we have more space. So what I want to do is I want to separate the line out part, the headphone output part, the digital encoding part, the USB part, digital input part. Every part have a good physical distance. It grouped together. So let me show you what's the overall layout here. You will know what's the effort we put in here. So for example, this one. Originally that was a Geek Pulse power input, but now we don't need to have that external switch. So we have the internal connector here and here that will get the power from the other internal power supply board in DAC going here. And we still got a lot of local regulators. And then we are talking about here. This section is the digital input part, the audio input. So it's isolated in one part. And this is XMOS, you can see. This is the USB. So you can see this group binding together, and we feed it all the way up to the two new ESS DAC here. This is a second group. You can see every capacitors, every IV amplifiers, power supply, and even a lot of reclock circuits all in this group. Alright, third group, the power supply and also the femto clocks going here. You will see a shell, the 4 holes for the shell, so you will see a shell on top of this clock circuit. So overall, you can see it's a very streamlined design. You got the digital audio input all the way to the ESS DAC and clock feeding on the top going down. Then you have two big sections. This part is a very nice, just like Geek Pulse, a full dual mono, fully balanced analog output. And we even add the relay here, so you won't have the power up. Boom. Okay, going up here, this is the two headphone analog output. So you still have the caps, have the other supporting circuits, but you can see 2 output there. And here is the digital input circuit. We will get it from display board. The display board will give you a sampling rate, the menu control, the IR remote, this kind of things. So that's the basic the layout. But as you can see, since we have more space, each groups have the distance they can work out at its best status. And also for the power layout, we are very easy to do the fast noise cleanup and the ground management too.
Perfect. Thank you so much, Larry.
Thank you.